In the quantum world, particles vanish, reappear, and even tunnel through walls. But what if, inside that wall, time just stops? One interpretation of quantum mechanics, the Bohmian model, predicts just that particles could be trapped in a timeless pause, locked in the act of tunneling forever. Bohmian mechanics offers a twist on traditional quantum theory. Unlike the well-known Copenhagen interpretation, where particles exist as blurry probabilities until observed, Bohm's theory treats them as real, definite points guided by an invisible wave. In this model, particles don't vanish into uncertainty, they're always somewhere, moving along hidden paths shaped by a pilot wave. And here's the wild part. If a barrier is infinitely long, the particle, according to Bohmian theory, would just stop inside, forever. The dwell time, the time it spends inside the barrier, should be infinite. But now, researchers have put that claim to the test. In a new experiment published in Nature, scientists built a system that simulates an infinite barrier for a photon. Using two precisely engineered mirrors and nanoscale ramps, they created a quantum playground. Lasers generated photons and controlled their motion down microscopic tracks, called waveguides. As the photons tunneled through the barrier, they bounced between waveguides at a predictable rhythm, revealing how fast they moved, and how long they stayed inside. By measuring the rate of decay and combining it with the timing of the jumps, researchers calculated the tunneling time, and the result? Finite, not frozen, not infinite. The experiment challenges Bohmian mechanics, showing that the photons did not behave as if they were stuck in timeless limbo. The findings suggest that the Bohmian trajectory model may not match the real-world behavior of tunneling particles. But it doesn't close the case. The experiment used an analog setup, meaning it mimicked the behavior rather than testing the exact phenomenon in nature. So the conclusion isn't final, and may itself be challenged. Quantum mechanics is notorious for interpretation debates. The Copenhagen model, Bohmian mechanics, many worlds, pilot waves, each offers a different lens to view reality. So is time frozen during quantum tunneling? This new experiment says no, but in the quantum realm, every answer leads to more questions. If you're fascinated by the mysteries of the universe, don't forget to subscribe to LG News for more mind-bending science stories. Because the universe, at its smallest scales, is still rewriting the rules of reality.